In our work, we studied the influence of soil salinity on the bearing capacity of the frozen wall. This study was carried out by a team of researchers from Perm Mining Institute and Minsk Institute of Natural Resources Management. The construction of vertical mine shafts in water-saturated and unstable soils is usually accomplished using artificial freezing. Additionally, during the construction of potash mines, frozen soils are often not only saturated with water, but also contain different salts. The salinity affects both the temperature distribution within the frozen soil and its load-bearing capacity, which is crucial for withstanding external pressure without collapsing or deforming excessively. We investigated the strange characteristics of frozen soil containing dissolved salt. This topic forms the basis of our study, which aims to elucidate the effect of dissolved salt on the long-term NaCl strengths of two types of soil. The studied chalk and clay samples were collected from the artificial freezing depth interval of a mine shaft under construction. Chalk and clay were crushed using a laboratory mill and sifted through a 5 mm mesh sieve to eliminate foreign inclusions from the selected soils. Salt in powder form was added and thoroughly mixed with the soil solid particles. Three types of salts were studied: natrium chlor, kalium chlor, and calcium chlor 2. The calculated amounts of salt required to lower the freezing point of the sample by a given value are presented in the table. We determined the ultimate long-term strengths of saline clay and chalk samples under uniaxial compression at various temperatures. Then we determined the temperature dependencies of the unfrozen water content for the same clay and chalk samples. By combining these results, we were able to obtain the dependence of uniaxial compressive strengths on the amount of unfrozen water. The points corresponding to individual values of temperature and type of salt are presented in figures A and B. From these figures, it's clear that for both soils, all points fall on one curve, which has a hyperbolic form. In our study, we also found approximated expressions for both curves, which were further used to analyze the load-bearing capacity of a frozen wall during the construction of a mine shaft in saline soils.